Alright, today I want to play with the idea, stole the idea from some of y'all who are in another class, of implementing a fractions class. And now it'll probably be somewhat different than what you're doing in that class, so it's not like you're going to be able to copy and paste the code. But what I want to do is, let me just pop open Notepad. I did start the recorder, did I not? Yes. Is say once you've declared your fraction f1, 1 divided by 2, that's going to be your fraction, and fraction f2, 2 divided by 3. Then if you do f1 plus equals f2, I want the 2 divided by 3 to be added to the 1 over half. Or if I do times equals, I want those two things to be multiplied by each other. So we're going to need a couple of data members. Class fraction. I may as well actually type this in because then I'm just going to turn around and cut and paste it anyways. So let's get a new project going. We're going to need a source.cpp, but let's also do the add class thing where we create a class. But we're going to make it all inline. So anyways, add new item, source.cpp, all well and good. Now let's add another new item, a class. Just going to click add, and we're going to give it the name fraction. I guess I'll leave it making a CPP file, but I don't think we're going to actually use one. I hope that's not a problem. Okay, so source.cpp is where our main's going to go. Don't put your main inside of fraction.cpp. So we need good old boilerplate. I'm not going to even read it aloud. Alrighty. Now I'm going to blip back over to fraction.h and we're going to work on that class. When we did the new class, it gave us a constructor and a destructor, and we really don't need either. But I'm going to leave them there. So we have two pieces of data, the denominator and the numerator. Let's make them whole numbers. Let's make them private, just to be awesome. Private int denominator int numerator. I'm just going to call them denom and numer. Make them easy to type. And if somebody creates a fraction without specifying any values, I want to just initialize them to 1. So I'm going to do this. Denominator is equal to 1, numerator is equal to 1. That way I don't have to worry about somebody creating a fraction with the value 0 over 0, which would be real bad. Why? Because if you divide by the integer 0, then you get an error. All right. Go back to the source, to main. Can I somehow get these side by side? Yay. Let's test what we've got so far. Fraction f1. I just want to see it compile. Now it didn't work because I forgot to put the include on it. Pound sign include quote fraction dot h. I had to put that inside source.cpp. So this side, since you can't probably see the little teeny tiny file names, this is source.cpp over here, and this is fraction.h over here. Alright, I'm going to build it just to make sure it builds. Alrighty. Now let's add the two functions, print as fraction and print as double. These are going to be public functions. Neither one of them should change the data, so we're going to declare them both as const. I think they both can be void. They don't need to return anything. Print as fraction. All it needs to do is see out the denominator followed by a slash followed by the numerator followed by ENDL. And let's do print as double, where we'll actually divide one into the other and print the results. Void print as double. Double is equal to the, wait. Double D is equal to, I've got that backwards, don't I? The denominator is the bottom one, the numerator is the top one. I have those backwards. Swap denom and numer up in your print statement. Numerator goes on top, denominator goes on the bottom. And then up here, double D is equal to the numerator, and a D divided by equal the denominator. Then let's see out D. Alright, now that we've got a fraction over in source.cpp, let's actually print it out. F1 dot print as fraction, F1 dot print as double. So I just added those two lines over here to main. One failed. Alright, cout undeclared identifier. That's because I forgot to do the using namespace and the pound sign include and stuff like that over in fraction.h. So over here in fraction.h we need to include iostream, pound sign include iostream, and it's really considered very, very poor taste to do using namespace std inside a header file. We should just bite the bullet and add std : in front of the couts. std : in front of that cout. std : in front of ENDL. std : in front of that cout, and std : in front of that ENDL. Alright, that worked. Good deal. So hopefully it'll say 1 over 1, and 1 over 1 is equal to 1. Cool. I'm going to test it again. Except I don't have a way of setting the denominator and the numerator. I'm going to need to create a constructor that takes those two things so that I can create a fraction of 1 divided by 2. Or I could provide getters and setters. We're just going to say that this class is going to be so cool that we're never going to set anything. So instead we're going to set it through the constructor. We need to add a constructor. We already have one over here. It doesn't do anything. Uh-huh.
I have a fraction.cpp. Maybe yours is like that.
Okay, if you have fraction.cpp, you could actually safely delete it, but make sure there's nothing in it first. Double click it and leave it there. Leave it there.
Because when I run mine,
Let me come look. What we want to be able to do is do something like this. Fraction f2, and then we want to say 1 over 2. Now that's different than how you Java guys have been doing it. You do that new command. Fraction f2 is equal to new fraction, and then you put this stuff in there. And C++ lets you do this. But that's not working because we don't have a constructor that accepts parameters. We only have a default constructor that accepts no parameters. So we're going to add a constructor that does. And if we were going to put a handy little definition here, a constructor, if I could spell, here I go with my Java comments. A constructor, excuse me, Python. A constructor is a method that has the same name as the class and is called when the object is created. You don't have to type that, but I'm putting that in there for our notes. So we're going to put a constructor here. Got the same name as the class, but we want it to be able to accept 2 integers. Int top, int bottom. So this dot numerator is equal to the top. This denominator is equal to the bottom. So what are we really doing here? I'm ignoring the fact that it gave us a CPP and just doing what are known as inline functions. Inline functions are when you define the functions, when you not only declare the functions, but you put the body of the code for the functions as well in the header file. Otherwise, you're just sticking prototypes in there, just like this. They gave us a constructor, but all they did is give us a prototype. And if we go and look at fraction.cpp, we'll see the body of it, although it's empty. Same for the destructor down here. A destructor is a method that has the same name as a class, except it's got a tilde in front of it. And it is called when the object needs to be destroyed. That's where you delete anything that that thing needs to do. If you allocated memory, you need to release the memory. This isn't doing any allocation, so we don't need the destructor to do anything. Okay, so I'm going to save that one, come back over here, save that one. No. Oh, that's dumb. What am I doing there? Do you see the obvious mistake there?
Yeah, you're not passing them in as parameters, you're dividing one.
Yeah, what the heck is that division for? The arguments for a constructor are just like the arguments for any function. They need commas. All right, now I want to print that function too. Excuse me, that fraction too. I'm just going to copy those 2 other print lines and paste them, except change the F1s to F2s. All right, so 1/2 is equal to 0.5. Now we're going to kind of take a left turn and write a function that will calculate the greatest common denominator between 2 numbers. And why do we want that? Because our function may have been entered like this. We may have said that's 3 divided by 9. We would like for that to be simplified to 1 over 3. To do that, we need to find the greatest common denominator and divide both the top and the bottom by that greatest common denominator. And so I'm just going to take a stab at doing int GCD for greatest common denominator, int x, int y. My brain is melting. I may have to look it up.
Yeah, I don't even recall how to find greatest common denominator with that inside of programming, so.
I think we can do it like this. Int g for greatest common is equal to 1. And this is only going to work for positive numbers, I think. So this is not a real good solution. For int I for C for counter is equal to 1, C is less than Y, C++, if x mod g is equal to 0 and y, not mod g, excuse me, mod c. So first it's going to check, are you evenly divisible by 1? Yeah, good. Are you evenly divisible by 2? Yeah, great. You know, are you evenly divisible by 3? And we want to check to make sure both sides are. So if x modulus c, our counter, is equal to 0 and y modulus c is equal to 0, then that's our new greatest common denominator. And then down here at the bottom we can return the greatest common denominator. Let's see if that works. Let's print out a couple of greatest common greatest common denominators. See out the GCD of 2 and 5, E and DL. What is the greatest common denominator of 2 and 5? They have no shared number, so it's just 1. Can't do anything with it. How about the greatest common denominator of 5 and 25? Nah. Yeah, 5 and 25. That ought to be 5. So I'm hoping it'll print 1 and 5. Yep, it did. So our greatest common denominator code is working. It could probably be improved. It certainly does not work for negative numbers.
Could you kind of explain how that if statement works?
Uh-huh. What is this checking? We have a counter that's going from 1 all the way up to the highest number.
Okay, so if
That's not good either. This is going to need to be rewritten as well. But anyways, say this is counting up from 1 to the highest number. C is counting up from the 1 to the highest number. And say that x is equal to 2 and y is equal to 4. Well, is 2 modulus 1? What is 2 modulus 1? 0. So it's evenly divisible into x, and 1 is also evenly divisible in y. So that makes our greatest common denominator 1 at the moment,
okay, so it keeps going until that.
until we've hit the largest value. So we're going to have to actually keep going. We don't know whether x or y is higher, so we can't just arbitrarily do that. Instead, we're going to do int largest is equal to, is x less than y? No, is x greater than y? Question mark. X colon y. That'll get our largest value. I'm going to put parentheses and stuff like that to make it easier to spot what it's doing. I just don't want to have to write an if statement, you know. And then, as long as we are less than the largest value, I'm going to add one more test of it to make sure it really is working, and I'm going to go for 25, 5. because the GCD of both of those should be 5. Whereas the second one would not have worked before we made that change. Yeah, okay. So if you don't care to understand how GCD works, that's fine. But the reason we need GCD is so that we can simplify our fraction. The way you simplify it is you get the greatest common denominator of both values, and if the greatest common denominator is not 1, you divide both the top and the bottom by that value. So let's cut that and paste it into our fraction class. Just cut that entire GCD function, and we're going to make it a method inside fraction.h. I'm just going to come down here and stick it at the bottom. Whoopsie. Okay, there's GCD. I pasted it into fraction.h, and we're going to make a void simplify function. Simplify. So we're going to say int GCD is equal to GCD of the numerator and the denominator. And why are you tripping on me? Expression preceding parentheses. Okay, fine. Greatest. Is that going to do it? Huh. What do you know? Guess that makes sense. And then if greatest is greater than 1, because if it's equal to 1, then the numbers don't have any, matching factor. Then the numerator divide by equal the greatest, and the denominator divide by equal the greatest. That should simplify it, but we need to test it out. To test it out, I'm going to go back in and create another fraction. Fraction F3 is going to be 10, 5. And what is 10 over 5?
2.
Yeah, it's 2 over 1. So after we call f3.simplify, if we print it out, f3.print as fraction, and f3.print as double, we should see it say 2, 2 over 1. There were errors. GCD, identifier not found.
The same method too.
Oh, these 3. Cut those 3 lines off, the top of main. We don't need them anymore. We move that function into the fraction class. All right, 2 over 1. It did simplify 10 over 5 to 2 over 1, so I'm pretty happy with that. All righty. Now to me, the easiest things to implement are multiply and divide, because I know how to do those real easy. To me, addition and subtraction of fractions are hard. I may skip that.
Would there be a reason that our greatest common denominator is not working anymore?
Yeah, because we moved it into fraction.h, so just cut those 3 lines out. Or if you really want them there, do fraction.gcd, or fraction arrow GCD. No, I'm not getting it to work either way.
The reason I'm confused is how come the rest of them are working, but that one's not.
Well, the first one may be giving you an error. What do you mean all of them are working?
Well, we have all of our other methods working, but that
Well, because that one was defined in main, but we ripped it and put it into fraction.h, so it's no longer accessible here. So we're just going to have to delete them, in my opinion. In Java, we would make them static methods so that we could call them even though they're in the fraction class. Right off the top of my head, I don't know how to do that in C++, so I'm skipping that. Okay, so what operators do we want to support? Like I said, multiplication is easy, right? You just multiply the two numerators, you multiply the two denominators, you call simplify, and you're done. Division is just as easy, except you flip the fraction before you multiply them. So let's do multiply equals, let's do divide equals, and let's do equal equals so that we can compare to see if those two things are equal or not. So what is it called when you add support for symbols like that?
overriding,
Yep, operator overloading.
overloading, sorry. Yeah.
So we're going to overload two functions. Well, first we're going to do multiply. Operator times equals, and we're going to take another fraction and call it other. We may as well pass it in as a reference just to speed up. Okay, I'm getting an error here. Explicit type is missing. Is it void? Yeah. Okay, so this numerator. Oh, and now we run into a problem. I can't get the other guy's numerator and denominator out because I never implemented getters.
Can you not do other?
Well, I should be able, yeah, I can't do times equals other numerator because I made them private.
But we're still in the class, right?
Right, but other is actually its own. It's a completely different object as far as the compiler is concerned. So this now right here is just as bad as main is as far as accessing variables are. I can only get a hold of my own numerator, my own denominator. That's why we talk about this numerator and this denominator. I can't get a hold of the other numerator and the other denominator. I'm going to cheat for now and make that say public rather than private. I'm just going to completely avoid the problem, which is bad programming. Don't tell anybody I did that. It will bring shame on me. I'd be curious to see how the Java program did that. You provided getters and setters. That's how you did it.
Well, for my others, I didn't.
Really?
And that fraction one I showed you, I just did this dot numerator times other dot, and it still worked fine.
Wow, then why isn't C++ allowing it?
It didn't throw an error, did it?
Maybe it didn't. Maybe I'm just being paranoid. Okay, so this denom times equals other dot denom. Yeah, it's not throwing an error. Let's see if it actually works. This numer times equals other dot numer. And then let's call simplify on it. This simplify. Let's try it out. Let's go back over to main. Let's make two new fractions. Fraction f4 is equal to, or fraction f4 is equal to 1 over 2. Fraction f5 is equal to 2 over 1. And what happens when we multiply those two guys together? 1 over 2 times 2 over 1 is what? We should get 1. So F4 times equals F5. Now let's print them both as fractions. C out F4, followed by a colon, and then call print as fraction. And then C out F4 dot print as fraction, and then C out F5 in quotes, F5 colon, and then call F5 dot print as fraction. I want to make sure that it's changing the first one and not the second one, because it's adding F5 onto F4, or multiplying it actually. So F4 should change unless it was 1 over 1, but F5 should not. I don't think it worked. I think F5. Oh, wait. I made it F4 times equals F5. So once that multiplication was done, then both of them should have equaled 1. 1 over 1. Is that what I got? I don't think so. No, I got 2 over 2. It didn't simplify it. I think we're going to have to add a special case to our GCD function. I made a mistake in our GCD function. Go up to GCD, wherever it is, and where it says C less than largest, make it C less than or equal to largest. Because if you have 10 over 10, the largest common denominator is 10. So I just had to add this line to the GCD function. Line marked by that comment right there. That's the change I made. Less than or equal to largest. All right. So F4 after that multiplication is equal to 1 over 1, which is correct, and F5 was unchanged. It's still equal to 2 over 1. So that multiplication worked. So since we know we can do multiply, then the question is, can we do, then in effect we know we could do divide. It's just denom times numer, and numer times equals denom. So that's no great accomplishment. I would like to be able to support this syntax. Fraction F3 is equal to F1 times F2. So we're going to have to override another operator here.
And if we're overriding them in the header file...
Overloading, sorry.
If we're overloading them in the header file, does that mean they no longer do what they did beforehand?
Only as far as fraction is concerned. It doesn't
So
modify it.
Okay, so it only works on fractions.
Right, right.
Okay, never mind. I
Yeah.
understand.
So void operator times, which is going to take two fractions, right? It's going to take the front hand side and the back hand side. Fraction F1, ampersand F1, so that it can be copied in as a reference. Fraction F2. And it's not going to be void, it's actually going to have to return a fraction. Too many parameters for this operator function. I better Google how to override that. Operator star, C++, multiply. Well, a little bit too complicated for me. Where is the simple explanation? constant left-hand side, constant right-hand side. That's not looking a lot different than how I did it, but I didn't make them constants. Constant fraction, constant fraction. I'm just going to call them the same thing they did, left-hand side and right-hand side. Too many parameters for this function. Says who. If I can't figure this out, we're going to stop on that. But that's exactly what this shows. We're not returning a fraction. Fraction r for return is equal to the left-hand side. Return r. What is your problem?
Wait, if we're not returning it, then why are we making it a fraction?
Well, we are. We're returning this fraction that we just created. Even if it's just 1 over 1. That would be at the bare minimum make me confident that we could proceed. But right now it's complaining. It's saying too many parameters. But we know that if you're multiplying two things, you have to be multiplying a times b. You're multiplying a left-hand side by a right-hand side. I didn't define the right-hand side as a reference. Let's see if that helps. No. All right, somebody else has found something similar.
What I saw someone, or said someone that they made a two operand operator, and then chain called it like it did an operator on the inside and operator on the outside. That's weird.
You need to define operator equal outside the class. So it says. So what did you find? Our story till now. I'm not sure where I left off, but we have added this operator, times equals, and we have added the multiply operator, just operator times. Now this operator times actually does not change the value of the numerator and the denominator. It looks like it would, but it doesn't. We're not changing this numerator and this denominator. We're creating a new fraction and modifying it. So I can tag this entire function as const, whereas I could not do that for star equal because star equal actually changes the current values. So I'm going to tack on const there. Hope you saw that because I'm covering it up now. All right, so fraction 8, C out F8, and then F8.print as fraction. 1 over 3 times 2 over 1 should equal 2 over 3. So that's what I'm hoping the last thing I print out is going to equal. knowing that we could do this, we could implement the rest of them. We could multiply, subtraction, and division, and addition, you know. But I don't see much need for us to continue. I'm hoping that those of y'all who had to write this in another language are seeing that C++ is really kind of neat in letting you do it like that, right? You were having to call f6.mult parentheses f7, things like that, and then chaining multiples together. Y'all in agreement that this is pretty cool, or do you not care?
I think I actually like it, especially that you can't do it in Java. I mean, because it simplifies it, but I guess I could say that my brain would have easily wrote a multiplication method instead of thinking to override the
Right.
That is pretty cool that you can do that.
Yeah.
Because it simplifies it a lot to where you won't have to do chain calling like you said and everything. But
Yeah, it makes it easier to use over here, but it makes coding it a lot harder.
Yeah.
Breaks your brain a little bit while you're coding it. The end result is that you can do things like that, or you can do things like where we added them together, times equal like that.
okay, so if there isn't if you have a method in your header file that doesn't take like a calling object, you can't use it unless you in your main, unless you.
Well, that's called a static function in Java. I'm going to need to remember how to do that in C++. Let's go to the next PowerPoint. We're on PowerPoint 13. We're going to go look at 14 now, which I believe is additional stuff about classes,
Because that's what I was getting confused when you were telling me
about
that.
GCD.
Yeah, that
Yeah.
file wasn't working. But okay.
Yeah, we should be able to do it. So I stuck all the unused PowerPoints into one called Unit 3. And I'm looking for PowerPoint 14 because we're currently looking at 13. Here we go. So, more about classes. Instance and static members. An instance member is a variable in a class. Every object has its own copy. A static variable is when one variable is shared amongst all objects of the class. We could put a counter in it that was incremented every time a new fraction was created. And we could keep track of how many fractions there were. We'd have to put the incrementer in the constructor, the decrementer in the destructor, and so as fractions were destroyed, that counter would go down. I really find few examples of static variables. Have y'all done static variables in Java?
Yeah, but he didn't have us implement it. It just
Okay.
it was in the PowerPoint.
Yeah, it's just a weird idea. It's one variable that's shared amongst all of the objects you create from that class. Every fraction shares that variable if it's marked by static.
So static it's technically a class variable, I guess. Would be
Exactly.
the same thing?
That's the Java term for it, is a class variable.
Okay.
Okay, and a static function is one that can access static member variables. You use it when a function does not access any data in the class, or any non-static data in the class. And the GCD function, that's actually true. Because GCD, you take the parameters. Where was that? Right there. GCD takes two parameters, but it doesn't access this denominator or this numerator, right? So, not only could we mark that as const, but we could make it static. And then we would still be able to call it outside of main. Nope, I have to remove the const, but okay. So now I'm back to being over here where I can get a hold. I can use the GCD function outside of main. I can do fraction dot GCD. I can pass in two numbers, 10 and 5. Let me just see that out. See out fraction GCD 10, 5.
Colon, right? That's just
Yeah, is it colon, colon?
yeah.
Yep, there we go. Followed by ENDL.
Does our simplified method call the GCD?
Yes.
So if you put it in another, okay, that's weird. Even if it wasn't, you couldn't just use it in the main, but if another function another method calls it, it's still applicable, I guess.
Yeah, if it's made, if you declare a function as static, it means it can be called anywhere, even if you don't have an object of that class. We could do this GCD thing right here without even having created any fractions whatsoever,
Right.
because it exists, outside of space and time. It's not actually part of that class.
But that's just in the header file.
Yeah, it is in the header file. It's almost like it was part of a namespace rather than a class.
I guess I just got confused because the simplify method could use it before it was static.
Right,
So,
because it was
yeah.
in the same class.
Gotcha.
Right. Okay, we forgot to make the multiply function call simplify the way we did here. So I'm going to add the call to simplify here. I guess it would be f1.simplify. There we go. Alrighty, so let's see if we can come up with some notes about this. Operator overloading allows us to define operators that work on our objects. So we can do things like this. Fraction f1 1/2 fraction f2 1/3 fraction f3 is equal to f1 times 1, 2. That's about enough.
Quick question: when did you upload those Unit 3 PowerPoints? Were they have
About
they
30
been
minutes
social-
ago.
Okay.
Yeah.
I know that.
So to do that, you add a method to your class that looks like, for example, operator star, and then something in here. The exact syntax you can look up, or we could cut and paste it into the notes. Another one that is a very good idea, in Java you should always implement a dot equals. In this language you should always implement equals equals so that you can compare two objects to each other. So you can just do if fraction 1 is equal to f2. Rather than having to do if f1 dot numer is equal to f2 dot numer and f1 dot, you get the idea.
So that only works. Okay, so the double equal, I hate saying that because I keep forgetting what it's called, but that only works for ints, right? It does it.
Exactly. It only works for primitive data types until you start providing, either in Java you want to provide dot equals, and in C++ you want to do operator equals like that.
So
And that's why you check strings in Java like this, and then you can do if s1 dot equals, s2, whatever,
So isn't that like operator overriding in Java?
Well, no, because we're not doing if s1 equals s2 would be operator overriding. We're just providing an equals method, which is an override, but it's not overloading an operator.
So what would that method look like? I did one, but I did what you did right there, so that's why I'm confused.
Okay, in Java it would look like this. Fraction, that's our class, public equals fraction f2 or fraction other, and then you would, if this dot denominator is equal to other dot denominator, and this dot numerator is equal to the other numerator. Return true, else return false. Like that. That's how you do it in Java. And how you do it in our language over here is more like operator equal equal. It's going to be Boolean, so it'll return true or false. Heck, let's go ahead and add it. Let's go back to our code over here. We're going to add one more operator, which is equal equal. It's Boolean, so that it can return true or false. It's equal equal. Its parameter, the right-hand side, we're going to call it RHS for right-hand side. The whole thing is constant because it doesn't change any values in it. And so if this guy's numerator is equal to the right-hand side's numerator, and I've messed that up. It's not liking that. It worked up there. Expression must have a pointer type. I'd like to punt on that one. We know it's possible. We don't have to. Don't actually have to do it, in my opinion. How's that for wimping out? Okay, so a static variable is one that's shared among all objects of the class. A static member function is a member function that either accesses no data in the object or it accesses only static data. And what do you do with static functions? You provide helper functions, like this GCD function, greatest common denominator. You don't have to have a fraction in order to call GCD, but it's useful to have a function that calculates the greatest common denominator. So we tacked it on as part of the class, but it's not part of the object itself. You see a whole bunch of those in other languages, things like character.isDigit. That's a, and you pass in something like that. This is a helper function, which means it's a class method, not a member method. We did not have to create a character in order to call character.isDigit. All right, so friends of classes. Here's this thing that other programs, languages don't really have. A friend. A friend is a function or class. It is not a member of the class, but it has access to the private members of the class. So say you have some other class that needs to be able to get out the numerator and the denominator, and we mark those guys as private. It would be tough luck, if you're trying to access it from somebody outside of the class, somewhere out of the class. But you can mark that class, that function, as a friend, and then it is able to access the secret data inside it, the protected data. Let's add some terms in. So data hiding is making your data private, also known as encapsulation. Prof's rules of class writing. 1, data private. 2, methods public. 3, getters and setters, also known as accessors and mutators. 4, equal equal. It's funny that I'm not showing you how to do equal equal, but if we were good enough at it, we should do equal equal, just like in Java. You should always provide an equals method, and in Java you should always provide a toString method. I don't know how to do that in this language. There's nothing called toString. So did I have any others? Oh yeah, and custom constructors if they make using it easier. Parameterized constructors. And then 6, if the class allocates any data or opens any files, the destructor should free or close that file. All of these, I'm going to push down the equal operator. Down 1. I really want you to have 1, 2, 3, and 4 memorized, because those apply to every language. Maybe not every language, but in Java and C++ and a lot of other languages, Python, that's generally what you want to do. Make your data private, your methods public. Doing that is known as encapsulation or data hiding. You add getters and setters. You do custom constructors. Now, why didn't I add getters and setters to this? Because you already knew how to do it. I don't think I want to talk too much about friend functions. Memberwise assignment. You can use equal to assign one object to another or to initialize an object with an object's data. If you do this, instance 2 is equal to instance 1. It copies all the member values from instance 1 into instance 2. And that is horribly different than Java, by the way, which is if you do this, it just copies a reference of instance 1 into instance 2, and now they're both pointing to the same memory.
Do you ever mix Java and C++ up a lot? I mean, with
Well,
remembering
when
that
I'm typing up here, yeah, but not when I'm thinking about it, if you know what I mean. The concepts I get clear and separate, but when I'm just sitting here typing, and you type by habit, then I'll start typing the wrong thing. So a copy constructor is a specialized constructor that is used when a newly created object is initialized to the data of another object of the same class. The default copy constructor just copies the fields. Numerator gets copied in a numerator. Denominator gets copied in a denominator. If that's enough, and what that gives you is the ability to type things like this. Fraction F2 is equal to F1. Or, F2 is equal to F1. In this language, that copies all the members, the denominator and the numerator, into F2, and you're done. But what if you needed a more complex copy for some reason? I can't think of a reason. Hopefully they'll give us one. But if you need something more complex than just copying the members from one object to the other, then you need to write a copy constructor. Problem: what if the object contains a pointer? I think we're also going to skip this. We haven't had call to use operator overloading. I'm sure that this shows us how to do the equal, so if we wanted to, we could do that. We haven't had reason to use the destructor yet. So we're going to write a class that needs a destructor. The reason it needs a destructor is because it's going to open a file. So here's what our class is going to look like. It's going to be called student. And so when you create a student, you're going to give them a name, Bob, and you're going to give them an age. And that's dumb. You're going to give them a level, like sophomore, junior, senior, and give them a school. So it's going to need 3 pieces of data. It's going to need 3 member variables. Once it is created, we want to be able to save that. I'm not really coming up with a good use for the destructor in this case. No, not doing it. I mean, yeah, that'd be a great. We could make it save and load from a file, and we may as well do that, but it's not going to demonstrate the need for the destructor because we're going to close the file as soon as we're done reading from it or writing to it. So it's still not going to need a destructor. The destructor is the opposite of constructor. It's just called when the object is freed from memory. You don't invoke it yourself. You just let it invoke it as the object disappears from memory. All right, this will be good enough anyways. So you can do s1.save, and it's going to create a file called bob.txt. And then if we make a new student like this, and we do s2.load, and we give it a file name, Bob, like that, it will load from bob.txt. So that student will magically be reconstituted. So we're going to create a class that does that. So it's going to need several members. It's going to need a name. What do you call that, sophomore? Junior's business. Level. It sounds like, you know, a video game. Standing, rank,
It's the year of study.
year. I like that. Let's do year. Okay. So we're going to need 3 members. We're going to need a name, which is a string. We're going to need a year, which is a string. We're going to need a school, which is a string. Those are the 3 things that our class needs.
Are we gonna make it inline again?
Yeah, and we should provide getters and setters, but I'm not going to allow us to call .set, so we're going to provide 3 getters. Get name, get year, and get school. All of which return strings. And then we're going to need a save, and we're going to need a load that takes a string, the name of the student, so that it knows what file name. So we can save a student that way, and we can reconstitute it like that. I think that's adequate. All right, let's go do that. Go back to your code. I haven't been wandering around and asking if people are doing okay. Are y'all okay? You need typo corrections? Okay, just a sec. When you added this code domain over here, oh, come on back. Wherever I put it. Oh, it's hidden there. I didn't actually check to see if it worked. It looks like it's working for me, but it's not working for you, so we're just going to comment it out because I don't want to figure out what's broken about it. So if after you added that, if you're getting an error there, just comment that out. I'm sorry for wimping out on you, but I have no idea of why it's saying what it's saying. All right, let's take a break. We've been here for an hour and 15 minutes. Come back in 5 minutes. Well, I'm going to take a break. Nobody else? Whatever. Be right back. It'll work once we comment it out.
Could you, before you go, could you put the student stuff back up?
Yeah, sure. All right, guys, what we're going to do here is we're going to implement this class where it does loading and saving from a file. In some disciplines, that's known as serialization. You're going to serialize your data from the file. That's more a C# and .NET term. So we need to write a class. We're going to call it student. Bless you. So and for this, you may as well just make a new project since the other one's giving you grief. I'm really sorry.
No, it's fine.
Something's got a hold of that exe and not letting it close. Go bye-bye. On these PCs here, you can right-click and do what is locking this file, and it would tell you what had it open. No, it wouldn't, because Lock Hunter can only be run on an administrative account. Okay, got my hopes up. Alrighty, so whether you make a new project or just continue on this one, right-click on Source Files and do Add Class. Our class is going to be called Student, so just click Add, name it Student.
For the our save, do you want that to just output all of the students' information to a file?
Right, it's going to write it out one per line, or maybe just one separated by a space. Now, if we do one separated by a space, it's only going to allow a first name rather than a first name, last name, but that'd be okay. Okay, so we need some variables. We're going to make several strings, so we're going to need to add some includes to this. Let's just going to assume that we need IOStream. I also know that since we're going to be using file access, that we're going to need fstream. And let's just include string as well. And let's cheat and go ahead and do using namespace std. Okay, so now that we added on our includes, we need 3 private strings. String student name, I'm just going to make it name. String year, rank level, and then string school. And let's give some default values. Name is equal to unknown. Year is equal to unknown. And then school is equal to unknown. Just so we have something to look at as soon as, even without writing constructors and stuff like that. We should provide getters and setters for them all. It really doesn't take that long. I guess we should just bite the bullet and do it. So, setters don't need to return anything. They can all be defined as void. Void set name. Takes a name and sets this guy's name equal to name. I'm going to kind of condense my syntax considerably by putting the entire setter on one name, on one line. I did restart the recorder, didn't I? Yes. Alrighty. Do the same thing for set year, string year. This guy's year is equal to the year parameter that was just passed in. And set school takes a variable, a parameter named school. Which sets this object's school equal to the parameter that's passed in. Alright, now we need 3 getters. Getters actually have to return the data, so we're not going to declare them as void. String get name, but they don't accept any parameters. And they don't change the data, so we're going to mark them all as constant.
I didn't know you wanted me to.
So return the name, or this name if you feel like using the this reference. String get year, parentheses in parentheses, it's a constant, and it returns the year. And string get, all of these are public by the way, so we're going to have to cut them and paste them below the word public, or move that word public up, that'd be easier. and get school is a constant, and it returns school, or this arrow school, if that's to your preference. All right, we've done our accessors and our mutators, our getters and our setters. I needed to have this line public above set name, or else nobody could call it. So I'm going to cut that line that says public colon and move it to after the variable declarations. Let's add a constructor where we can pass in 3 strings. We have this constructor, but we're going to make a better one. Student that takes 3 strings. String name, string year, string school. Set name the name, set name the year. Java complains at me when I do this, so I got out of the habit of it. Or set year the year, and set school to the school that was passed in. I'm curious as to whether I'm going to be able to get away with this, so I'm going to build this right now. I always got an error when I did that in Java. Not an error, a warning. Seemed to work. Okay. So that's our customized constructor, our parameterized constructor. We have the default one. The default one's just going to leave name, year, and school like that. And let's add a print function. It'd be cooler to override arrow arrow. Maybe we'll do that if we have time, so that we could just type this. Don't type this. But it'd be neat if we could do that, and it would send the entire object to cout. But in lieu of that, we're going to do print. It's going to be void because it doesn't need to return anything. It's going to be constant because it doesn't change any data in it. And we're going to cout the student's name, followed by a space, followed by their year, followed by a space, followed by their school, followed by an ENDL. Alrighty, I'm going to go back to main and test this. I'm going to close fraction.h. Don't need that anymore.
So our save function could just output print, right? Would that work?
If we were directing it to cout, we would need to override the arrow
Oh, yeah.
in order to do that. Okay, so at the very top of main, or if you started a new main, that's totally cool. I did not realize it could pop out the CPP file entirely. That's kind of cool, actually. Alrighty. So up at the top of main, I'm going to create a new student. Student S1, whose name is, surprise, Bob, who is a senior. At Rose. Just put single words there. Now I'm getting an error here. Student is underlined. Why is that?
You didn't include the...
You're right. I did not add the include for student. So come up and do include quote student. dot H. And you remember why we're putting quotes rather than angle braces around these header files?
That's user created, right?
Yeah, they're user created. More specifically, they're in the same directory as the CPP file.
Okay.
All right, and then I'm going to print them out. S1.print. Just print that student out. I want to see it say Bob Senior Rose when I build them. All right, Bob Senior Rose. Right there. All righty. I'm going to add a save method. It doesn't need to return anything, although it could return true, you know, Boolean if it did save it, and false if we got an error. And it's not going to take a file name because it's going to base its file name on the name of the student, which may be a really stupid thing to do, but let's just go with it. It's a constant because it doesn't return, it doesn't modify any of the values. Now we need to create our file. OF stream out. I've already forgotten the syntax.
Just do a stream out without the.
Without any equal, and then out dot open.
I tried to do that, and then it gave me an error. It said it didn't have a. What was that? For some reason.
We need a file name, so string space file name is equal to the name of this student.
Nope, it's throwing it. It's doing it now.
Okay. Name of the student plus .txt. All right, supposedly we could just do that. My file.open, pass in a file name. You're getting an error, so let's see. So out.open, pass in that file name. Let's write our three pieces of data out. Out, arrow, arrow, not C out because we're not writing to screen. We're writing to our file, followed by the name, followed by ENDL, or space would work too. And then the year, followed by ENDL, and then the school, followed by ENDL. Now Reed's going to do the opposite. Oh, and we need to close the file. OF stream. Nope, out.close. All right, Nadrian, I'm curious as to what error you were seeing there. I do want to go ahead and test this, so I'm going to call s1.save over here.
It's not throwing an error anymore.
Oh, good. All right. Going to rebuild, so I'm going up here to rebuild solution, then run it. I don't see that it saved it, but it did. To verify that, I need to go out into the project directories. Go out where your projects are stored, go into the newest project, -15. If we look in the debug directory, is that where the text files are stored? Nope. In the project 15 directory, there it is. There's bob.txt, which has got our three pieces of data. Bob is a senior at Rose. All right, so that's what main looks like. Now what we want to be able to do, and this is not going to work, just because we haven't added the code for it yet, is make a new student like this, student space S2, and then do S2.load Bob. But we don't have a load method yet.
Will it save it if you don't close
I don't know, I just Control S out of habit after I'm done typing.
Well, if you didn't save your file, I mean, like the file we're writing.
Oh, the notepad? Yeah, I just close it. All right, so let's write load. Load does take a string, which is actually the name of the person we're loading, but that's okay. I'm going to leave that idea alone. As a matter of fact, let's make it actually be the whole file name, bob.txt. I don't know if I really like that idea or not, but let's go with it. Come back here. So, again, it doesn't need to return anything, although making it return a Boolean to whether it succeeded or not would not be a bad idea at all. It accepts an argument, so we need a parameter called file name. We need to declare an IF stream. In.open the file name followed by R for reading. That didn't work.
See, that's not. I think it only takes. Well, you already open it for reading, so you don't.
Oh, it's an IF, so it's already defaulting to reading.
Yeah.
Sorry guys, I slipped into Python there. Yeah, I do mix up my languages, sorry. Okay. Now we need to read it. We ought to just be able to call like this. IN arrow arrow into our name. IN arrow arrow into our year. IN arrow arrow into our school. Now we're not checking any error messages at all. We're just going to pray, hope and pray that it works. So is this great programming? Not at all. But it's just illustrating the concept of an object that reads itself from a file name.
If your constructor, if you use the same, like you see how you're just doing in name, in year, in school, instead of this name, this year, this school. If you have your constructor parameters named the same, would it be wise to just do this?
I like using this. It's just saving some typing to not have to do it. There would not be anything wrong with going and adding the this keyword to this reference to all of our variables. Nothing wrong with doing that.
I just didn't know if you didn't do it and you had another variable defined as
Right, if I had another variable named name for some reason, then I absolutely would have to prefix it with this reference to get it to work.
Gotcha.
And how about a version of a constructor which takes a file name? We have one constructor here which accepts 3 strings, which is the name and the year and the school. But let's write another constructor that takes a file name. It's going to only have one parameter. And all it needs to do is call load with that file name. So now we can go back to main and do student S3 and load from the file name. Like that. I actually like that better than that student S2 business. I think that's pretty slick right there.
If you define that constructor above the load, it should still find load, right?
That is correct. It should. Is it not?
Okay, it's doing it now.
Okay.
Mine is just acting super.
And I haven't printed out student 2 and 3, so I'm going to do that now. S2.print, S3.print, and then test it out. All right. Hope that was enough to illustrate the idea. Objects can save themselves to a file. Objects can reload themselves from a file. To me, it makes sense to make a constructor that accepts a file name. On the other hand, if your object is already written in such a way that it has a constructor that accepts one string, only, then you can't provide another one. You can't overload something with two versions that just accept one string. When you're overloading the constructor, you have to make sure each version of the constructor has different parameter lists. And we have provided three. We have provided one that doesn't take any parameters. We've taken one that takes 3 strings, and we've written one that takes 1 string. So that abides by that rule. If we wrote another constructor that only accepted 1 string, then we would get a compilation error because it wouldn't know which one we meant.
Oh, okay, that makes sense. Okay.
Let's actually pull up the code as it was and let me do a walkabout, make sure that everybody got it up and running.
Cause I was kind of confused, cause like I always thought if there wasn't a lot of people enrolled in the class, it gets dropped. But I was the only one in Mrs. Haynes' access class, so it's just me and her for 2 hours and 40
Oh, that
minutes.
is funny. That is funny.
So it didn't get dropped. She just moved me into the online.
Oh, she had an online version that made, and so she just moved you into the online one.
Oh, okay. So
Yeah.
technically the class did get dropped, but
But she
I
happened to
wasn't
have
on.
another section that she could put you in.
Gotcha.
Yeah. Okay.
And you don't teach advanced Java just online in the fall. right?
That's correct. In the spring is a lecture.
But yeah, I'm trying to come
So here's what we've added. I'm speaking now for the benefit of the recording. I had it paused. We have a student array. We've declared it with 3. What I really should do is instead do a const int num students equals 3, and then I can use that variable like that. Student SA square braces num students, and then down in my for loop here, I can do for I is equal to 0, I is less than the number of students, I plus plus. Or I could have calculated it on the fly. If you remember how to calculate these things on the fly, it's the size of array divided by size of element type. Yep.
So the constant that we have for num students, would that be a good class variable, I guess I say? Like every time you create a new student, or like you put it in the constructor that you add 1 to the.
Well, you could have a static type that was the number of students created, but then it would be incrementing every time you created a student, whether it was part of the array or not.
Oh, okay, gotcha.
That's why you make your own custom data type that replaces the array class, and it keeps track of the number of things added to it. Every time you call .add or .append or whatever, it increments a counter. All right, let's run it, see if it works. All right, and it printed our data out 2 times. Sue, Beth, and Jack, Sue, Beth, and Jack. So we created an array of elements, and we wrote 2 for loops to iterate through that array. And with that, I'm happy enough with the progress we made. The things to remember from today's lesson, not that I've created very good notes, are, again, operator overloading, so that you can do plus equals, times equals, equals equals, stuff like that. And now we've done an example of file I/O, saving an object to file, and loading an object from file. And then we demonstrated an array of objects.
What would be the reason that it saved your project in our debug folder instead of normal?
Good question.
I put all my stuff in the debug folder for some reason.
All right, let's make a Dropbox for this, and then I'll bring the code back up. No homework based on this. It's too late in the semester. Although I gave my fundamentals class homework to turn in on Monday. I'm not going to do that to y'all. So N is going to have student.h, what was that other class we created? Fraction.h and source.cpp.
Yeah, I think I did. I think I did something wrong. It made my student. It made an application.
Huh.
And every time I run it, it actually runs the main. That's weird. It runs the main.
All right, there's a Dropbox now, N as a number. If you're done, you want to upload it, that's totally cool. Upload it and leave. Let me bring the source code back up for those who are not.
So do you just want me to turn in the application?
Yeah, just turn in the ones that you got there.
Okay.
You can find the .h file that we did earlier, hopefully.
It made the CPP an object file.
That's weird.
I don't know what I did wrong. I apologize.
That's just what I was wondering, was if that was gonna take Java as well. I don't wanna get all jumped.
I didn't know the computer science